Do you need to say something ahead of?
Yeah.
Okay, then let's get started with that.
Hi, everyone. Hi.
Just
Yeah, thank you for being so patient and waiting. And thank you, Rajat, for coming. So, you already know Rajat has his slides up, so I'll not steal his thunder. So, he's works on Kubernetes project from Red Hat. He has plenty of experience behind him on networking and ingress. I'll let him do rest of the talking.
Okay, thank you. Thank you, Sujata. And these are not really the slides. This is like a live internet statistics things going on. I try to bring this up every time I want to talk about networking and the internet or the containers in general or the future or what has been going on. It's just so fabulous to look at, and I'm sure you probably agree with it. It's not boring. And there's a flick of things that you can do and see. These are things that are sent today, and if I look at flipping and what was sent this year, I don't even know what that number is, whatever trillion beyond that, what happens and stuff. So this is what is going on as we are living, breathing around the world. The internet is a living giant now, and what is empowering it is, of course, the network, the networking, packets moving left, right, center. And even more important is the reliability of internet, which is what my talk roughly is going to center around today. And I'm going to talk about containers. It's kind of a techie topic. The rest of the afternoon today, I saw so many talks which are deeply technical and useful. So this one is not so technical, or maybe a little bit technical, but we're going to talk about a general agenda of things on what is going on with containers, what is going on with networking with containers, what are the extraordinary things that we're seeing because of the advent of containers, and take a little bit higher level view of what we need to solve, what are the problems that we're going to get to see because of the scale of things when containers get deployed over the internet. So really the internet is going to function with containers. I have no doubt about that. So for the rest of the talk, kind of lighten up a little bit, and I'm going to start with what happened with me on Saturday, which went by. I was trekking a little bit, and I hit my foot somewhere, and I got a minor cut. And I said, whatever, that's fine. And on Sunday morning, I was supposed to golf, and it turns out I had a big swelling. So it was kind of not pretty. So I decidedly, disappointedly, didn't go for golf, had to go for urgent care. And the doctor started to examine what's going on. And they found that there was a reddish stuff going on the foot. And there was a line which was developing, traveling up the leg. And I thought, okay, that's fine. How bad is it? And the doctor says, 200 years ago, it was statistical. If that red line travels up to your heart, you're dead. Or you may not be dead, but nobody can do anything about it. But fortunately, we live in the world of antibiotics, so that's where it is. I thought it was pretty scary, that what if it could have traveled, and what really is going on? So then the two ways to learn about your body or the medicine or the healing about it. One way is to learn medicine, become a doctor. The other is to become a patient, and you know what is the antibiotic that you gave, what does it do? So I read about it. And I knew there was this talk coming. But funny thing is that then I learned that these antibiotics work by killing those bacteria, but there are these cells which are coming by, how many bacteria are we talking about? I didn't know. How many cells in the body we're talking about? It's probably trillions. So what happens is, this is a number, but of course from, it's correct from the Google search that I learned, that there are about 20 billion cells that are replaced in our body every day. About 300 million of them every minute are replaced. I'm not talking about the number of cells we have. They are replaced, which means they are born and they are dying and replaced by new ones. While the body as its whole is kind of not aware of it and is somewhat functioning, except when things happen like those. And that made me start to think, what's going on with this internet? It's a network. It's kind of robust to things dying somewhere, but things recover because there are things being replaced. And that's what a sustainable model is. When I would like to borrow that idea of the internet as we know, and the body, especially as we are learning how it functions, that it's kind of robust to stresses because we replace things. And that's probably the theme that I want to look at when we talk about containers and networking. It's kind of strange, but I'll hook it up. Coming back to I'll put the slides up first. And then I got this picture. It was fascinating to see how cells of the body need oxygen to live or whatnot and everything and nutrients, and they're being supplied by this network. And this is, of course, stolen from the internet. Don't worry. What if something goes wrong? It's kind of secluded and removed and replaced. That's how the body functions. And when the spine is telling the hand to move, does it have the hand's IP address or something in some way, or the cell's IP address? Well, it clearly knows that this is where it needs to go, which exact muscle need to move, which exact cells need to, but the cells are actually being replaced. So what's going on? It's something that we call as a virtual identity or something, and it's being controlled by this nervous functions. But what really happens over there is kind of replaceable, is fungible. And that thought needs to be mixed with this new idea that I was learning. And if any of you in the audience or who are listening online have read this book, any of you have? You have, wonderful. It's a book called, this is my personal copy, and I just took a picture this morning. I thought I'd insert it. And it's called Anti-Fragile. I'll just roughly touch upon this topic, and then the rest of the slides will try to make sense of what is going on as we try to build these complex systems using containers, using compute clusters, whether they are part of a single cluster or part of a distributed cluster, or these clusters coming together, traffic going from one compute node to another, or one compute cloud to another, and what's going on. What we want to develop is an anti-fragile system. Now, we all know what a fragile system is. A fragile system is something that we give stress to it, it falls down, and it breaks. It does not recover. What is opposite of fragile? Of course, it's anti-fragile, but what we clearly knew about what opposite of fragile is robust, which means if you give it stress, it does not break. But that's not opposite of fragile. Opposite of fragile would be that if you give it stress, it actually becomes better than it was before. If you give it stress, it breaks. It means it was fragile. If you give it stress and it comes back, not only not broken, stronger than what it was, that's anti-fragile. And that's what we want our systems to be. The human body is the great example. When I give it stress, then the muscles actually become better than what they were before. If they do not give it stress, they actually decay. So there's a automated learning, something distributed, nice stuff going on, which is what I think the internet is becoming also. The more you stress it, their engineers will go and fix it. And now we are better than before because that problem is fixed. Next time that problem happens, that stress happens, we know how to deal with it. We are not only robust to that stress, but we become stronger than what we were before. Now, container networking. This is statistics from 2014. It's probably still, maybe 2015. It's kind of real, again, I give the reference there, but 11% of containers, and I'm not going to tell what containers are, it's probably an educated audience here. 11% of containers live less than 1 minute. 27% of them, which were launched, they live less than 5 minutes. Maybe the numbers are a little bit skewed here and there, but 46% of them launched less than an hour. That's not so bad. I mean, maybe people are trying this test stuff. Maybe there's some long-running containers. But the idea is that I want this to happen, actually. There's going to be serverless computing. You guys have heard of AWS Lambda, right? Where when something is needed, is launched for you. It's not like it's a monolith which is running inside your memory and stuff. It's called. When you need it, you call for it, and it uses some sort of network to get to it. You send the input, it comes out, and it was spun for you, and it was done for you. And in some way, serverless computing could be done by containers. And in that case, the 11% figure should clearly rise.
So, but then whatever you spin still runs on a server. It is not on-premise or over the cloud.
So the question is, or rather comment is that whatever you spin is run on a server really. It runs on some hardware. But whoever is calling, whoever is using, whoever is going to ultimately use it or even monitor it, should it care where it's running? Do we care in the clouds today where your server was? Was it even a server? We don't even know how many layers were there. We just know this is the compute device. And similar paradigm has to shift towards saying, I need the service. I don't know where it runs, which machine, which virtual machine, which network, whatever. It was spun for me. I will send the input. Which OS was it running on? Does it matter to you? Does anyone care? No. So the application doesn't care. This is the agenda for today. I'm going to talk a little bit with the background that I had with the body, healing or not. And so what is different with containers? I think we're getting into that paradigm where the cells are coming and the cells will be destroyed when they have an error or when they are end of life or something, and will be replaced by a new crop of an upgraded system, or even just the same things. It doesn't matter that we need to upgrade it. And that's what's going to be different with containers likely. Some beauty points of container orchestration systems. Kubernetes is kind of the talk. And I work on Kubernetes, so maybe some inputs are biased, but that's what I'm going to talk about. And SDN, the network is really the computer. Then things to watch out for. Some things have been learned as we have tried choosing and running an SDN on a container orchestration system. Okay, so Google came out in 2015 or something, or 2014. They said we run 2 billion containers in a week, and that translates to about 3,000 containers in a second. There is a scale problem that had not been seen before. Why? Because containers need a network of their own. What are containers? They're just processes. There's nothing else. It's not a special thing. They're not spinning up virtual machines of the order of 3,000 of them per second. How many processes are running on your computer right now? Any idea? Probably 200, 300, 500. It's not a big deal that you run hundreds of them in your device. You have probably 10 or 12, 15 devices on your home. And at the scale of Google, I am not surprised they run these many processes. Your emails that I showed in the morning, in the beginning, they all are running processes. Anyway, they need a network endpoint. They need a network. That's what is new. So we need network endpoints to the order of 3,000 per second. It's a scale problem that we need to solve. And that's what the new sort of SDNs need to accomplish. And then we have nested workloads. Like what Sujata pointed out was, we have bare metal, some running somewhere on bare metal. Then we have virtual machines, then we have containers, and the list goes on. And there is container, inside virtual machine, inside bare metal. It's not a joke, it really runs. That's what Kubernetes CI CD tests are running with. So all of them have a network endpoint floated up right to the top indiscreetly. We have a scale problem. So I get to container orchestration, some of the beauty points. Before that, or do we have any questions or anything, or do you want me to steer the talk in any direction? Don't worry. Okay, Kubernetes service. Roughly, service is something that I was talking in the beginning, where the body is, the organs are composed of cells, but the organ by itself is a virtual entity. It's manufactured by those cells. But when you said liver, please do those functions of, it's the chemistry lab of my body, those cells are really doing it, but I don't address the cells really. I just need to say the liver functions like that. The cells of the liver are being replaced also. So this is what it is. When you go and talk to a service, which is a microservice or something, it's represented by several containers. But when you talk to it through a service IP. That always stays the same. You know how to address it. Even if the contents of that service are being replaced every minute or every hour or what, we don't care about it. The next concept is a sidecar and an init container concept, which is specific to Kubernetes, but very useful, is that you could run several containers as one kind of namespace where they run together. And if any of you were in the ISTIO talk or something, or the buzzword kind of talk, which is, you run service meshes and everything, they're for real. The advantages of sidecar are very apparent over there, and you could use the containers as a sidecar, and they could become a proxy, and they know who to talk to, and then direct the services and everything. This is something that which happens. Request routing between containers, microservices as they're numerous, load balancing, authentication, all the stuff that happens is now easily solvable through service mesh, where there could be an intelligent system. And service mesh does not mean that ISTIO is the way or something. It just means that there's a centralized logic somewhere which is sitting, which knows who is talking to who and can do some of these things for you, like circuit break and AB and stuff like that. And that has better visibility into what's going on in your compute cluster. And there was a talk by Tobias this afternoon. And he was mentioning about this microservices sprawling, and there was an incident of things and everything. But what really struck me was, and I borrowed a slide from him himself, is this. They all are true points, but please look at what is dumb endpoints, smart pipes. Please realize what this means in an internet probably, or a network, or a compute resource, or a facility which is computing your stuff like microservices are. You need dumb endpoints and smart pipes, because now become anti-fragile. Exactly how? Is because you can remove those endpoints, but the pipes are smarter, knowing that incident happens, they know and learn how to reroute, how to circuit break, how to do A and B. That's anti-fragility. And that's useful. If you do not have that, what you're stuck with are incidents like, hey, something wrong happened at some point in some service, and you have no clue what's going on. And by the time the reports come in, and then cases go, because the pipes were not smart. If so much is being broken down from a monolith to small services, small what's called microservices, then the pipes that are connecting the microservices need to be intelligent. Does that make sense? I'm just pausing because I think it's an important point. Another one is network policy, of course. We need security of things when are running. They're split into several, they're like broken down into several microservices. We need security between them, and network policy is something which has been done in Kubernetes. And this is something that the SDN or the monitoring pieces, they need to kind of pay attention to, so that SDN vendors can watch and react to these policies. They're kind of important. It's a beauty point, I would think. How do I choose?
Is it okay to make a comment?
Totally. There's a comment here, please.
Okay.
There's a microphone.
Yeah.
Please, thank you.
KRS Murthy. In addition to thinking, of human as an example, with endpoints and intelligent connections and so on, start thinking when the being starts, as a single cell multiplies, and then what kind of a code that is there in that. That's a totally different business compared to what we have in the electronic network, in the electronics-based network. And then how the body grows, how it grows into what it is. You became what different from what I became, and everyone became. The paradigm is not exactly comparable.
I would think so, yes. I think the
I
operational...
make sure I
No, I
talk to the
totally.
fundamentals.
Absolutely. I don't think I'm trying to say that the body is functioning the same as the internet. It's correct that there is some code of the body, there is a DNA, there is a map, there is controversial or not, but
Gene expression and so on.
there's so much stuff. But operationally, what I liked was what I would like to extend to these networks. Operationally, we have found that things regrow. The very fact that 100 million cells get replaced every minute is telling something, that there is something anti-fragile going on there in operations. What is the real logic? Of course, that's important. What really runs on the internet, it's important. What AI stuff we actually end up being, we are manifesting our own whatever is there onto the internet itself. The internet is not going to become something that we never intended or something. It's a map of our own intelligence, and in the future it's going to be like that. So that philosophical thing, with due respect, yes.
Yeah.
But operationally,
Next question is the distributed intelligence of the gene code itself that expresses based on which part of the body, what conditions, which is slightly different from what you are comparing to.
absolutely, I agree. How it evolves, how the computing cluster evolves is going to be different.
Yeah.
But how we want to make it work in terms of, we are the infrastructure people.
Yeah.
We want to look at these problems. Thank you for the input, though. How do I choose an SDN for my Kubernetes cluster? Now, this is also not just for a user who is going to run a Kubernetes cluster. This is for us developers, if we're here. And what kind of SDN we want to develop when it's going to be a container orchestration system. I'm going to run over these very quickly. There are a lot of these points. I don't want to delve on each of these points, but look at them. These are very critical questions that you as a developer or a deployer need to question and answer and say what is suitable for you. Do you need an overlay or you do not? Sometimes you would choose an overlay and you end up with a double overlay because you're running on a cloud. Remember, container in a VM in a bare metal stuff. So there'll be several layers to it. Do we need cross-cluster workload connectivity? Let's solve the small problems, and then the bigger problems can get solved. If you have that problem, solve it. Otherwise, skip it. Ingress firewall or egress firewall. Some deployments have to solve that problem, some don't. Network policy support, of course, that's important. The scale architecture. Is it going to be central controller based or a single point of failure, or it's going to be distributed? Scale. What are the number of containers we're talking about? Remember, 3,000 containers per second is Google's problem, not everybody's problem. If I have a 10-node cluster, you don't have that problem. So containers need to come up very quickly and go back, but the number of containers is not a problem. This frequency of containers may be a problem. It's a different problem. Service scaling. You might have few containers, but you have different kind of services running on it, especially when you're going from brownfield, you have a big monolith, it's being broken down into this thing, so you may need more services than actual containers. Quick ones, multicast support. You need it? You don't need it. It really recreates a mess. Whoever understands a little bit of networking, it can be a mess on having multicast support in SDN. External IP port ranges. These slides are accessible. I don't want to get into these points in detail, but each of them are important points. One point wrong, and then you might have a system which doesn't behave well with your workloads. Multiple networks. Latency between containers. Latency jitter between containers. QoS. Do you bring your own IPAM? Fast data path. It's not for everyone. Was I talking to Brian before just this dinner? And we were talking, not everybody needs SRIOV. Some people do. And if you don't, then don't bother with the SDN. Metrics. You need it. Probably a central dashboard from your SDN point of view. Then, of course, there's IPv6. There's a statement that I make quite often. I have a son who's 5 years old, and I think, or I hope, or I have a target that when he grows up, he will think IPv4 like that, past history, that the world will only run on IPv6. Maybe I'm totally wrong, because it's happened. I thought it would happen more quickly, but it hasn't. But we got to see. The SDN does it or does not. Please. More than the features, you need to worry about what problems exist. There's a security problem. If you have a central, and who was I talking to? Nikita, was it? Right. And she said there's a SDN being built up with a distributed controller system where so many containers are being born and brought and dying. In my body or elsewhere, we need a distributed set of management. Do we need one prime minister for the whole world who knows everything that is going on with everybody's life? No. There is a hierarchy. It's distributed for a reason. And that's where the intelligence needs to disperse also. And be useful to not have a central controller for effectiveness as well as security, because if everything goes to that central thing, if one of the things gets hijacked and has access to the boss, it's not going to be good. Some more. Now this is some text here, but and I can probably pick one of them. But one of the problems that we found, for example, running Kubernetes cluster, running thousands of containers. Look at the stale ARP cache issue, for example. The containers will come in and go so quickly, and their IP address, the network endpoints, will be reused so quickly that the client's ARP cache had not even expired. And I thought, this is the IP address. I'm going to go there. This is the MAC address. I learned it. By the time you get there, that container was dead. A new one was born. It took its own IP address, and then the routers know about it, but you didn't know about it, so you chose the wrong MAC address for the old IP address. And that's a problem you need to worry about at this scale. Was this problem existing before? I don't think so. Each of these problems are real problems. Please pay attention. Thank you. That's all. If anybody has question on why SSH to the server machine is going to come down, I am ready for a debate or a fist fight or whatever. Thank you. Questions?
That's my question. SSH server should come down. What about that? The answer to that question.
Okay.
SSH server machine going down.
Is going down?
Yeah, you just said it.
Yeah. SSH to the server machine will not happen in an ideal future or eventual future. Why? Is when do you log on to your application, you see, well, I want to see some logs. When do you put logs? Where do you put logs? You've written code, where do you put logs? I've called this function, did it enter that function? When it came out, what output did it give? But now you've broken it down into microservices. So where do you want to see the logs? Inside that function where it's running, or the actual network which knows whether that function was executed or not, and what the input was, what the output was. So the network knows it. The pipes are smarter and they know. You never need to log on to where that thing is running. If the pipes are smarter, you would know what was running, what was not running, what needed to run, what didn't need to run. So the monolith, yes. If you have ever put debug statements in a monolith, if you ever put loggings, if you have ever examined logs to debug problems, and I presume yes, you don't need to SSH into those modules anymore. We just need the pipes to be smarter, to report what went, what came out, whether it was invoked, whether it was not invoked, what was the payload, what was the throughput, what was the time taken. You have everything. What else do you need? You don't need to SSH into where the function is running.
I mean, there's a lot more to investigate there. I think that approach helps from a fabric operator point of view, strictly at L2 network. From a software-defined infrastructure, it's software code that's running this. You've got a network inside of the box.
Correct.
So how do you diagnose the individual functions that may be failing at certain scale, certain race conditions? So, in some aspects, it's the difference between logging and tracing.
Yeah, this is just kind of an insinuation to say that always there'll be two kinds of things to tackle. One is at the application level, for which you don't need the SSH. I insist, and I can explain. On the other hand, there's the infrastructure guy who needs to go everywhere. Even hardware will go wrong, and you need to send a guy to fix the electricity there. So yes, as infrastructure engineer, I need to go into every place possible, what is running where. But as an application, I don't need to know, how do you debug your cloud applications? Now you don't go and travel to North Virginia, wherever it is. SSH to the machine, but you don't even need that. As long as the things are reported back to you by those smart pipes, the application level debugging is not going to require SSH to the physical machine. Physical machine is lost. It reminds me of The Matrix, the movie, in which the machines were talking. It was all floating in logic. The gene expression was working. The exact details, where it's running, what is coming, it's not important.
Yeah, there was a slide where you said dumb endpoint smart network.
That's right.
So, you made a good case for the smart network, and it's not a hard case to make. But on the dumb endpoints, you didn't quite make that case. And in particular, you just gave a good example of how do you debug a cloud application. You have to that application, that debugging environment, has to understand things about the network.
Oh, okay. So one comment was about endpoints being dumb and the networks being smart. Networks being smart, we understood, plausible case. Endpoints being dumb is in the context of networks being smart, in the sense that in microservices, endpoints are replaceable. That's what we mean by dumb. They're doing smart work. Somebody is actually transcoding your Netflix video. It's not doing dumb work. It's dumb from...
Is it oblivious? Does it know anything about the network?
It
Does
shouldn't.
it know anything about the transport?
It shouldn't. It shouldn't. That's why coming up service mesh for the world, where I as a transcoder would know this is my input and there is only one way I can go. I don't need to learn that. The service mesh is already configured. NFV cases. I have 64 interfaces here. I am a container, 64 interfaces. Each of the interfaces gets some data where I don't need to do deep packet inspection, because the fact that it has arrived on this interface means it is of that packet nature. The nature of that packet is predetermined. And what do I process? I do some logic, some manipulation, and then I go out. It's already predetermined where I'm going to go out. I cannot even go anywhere else. The service mesh has decided for I as a function. When I was born, it was decided what I'm going to do, where I'm going to send the data. I don't need to learn. The service mesh is going to take care of that. It did that kind of solve. Maybe there's more questions, but...
Let me get back to it.
Yeah, quick, does this work?
Yes.
Yeah, Tobias can say. Quick question, or like addition, I think, to the dumb endpoints, right? And I think what we don't think enough about is how small those endpoints are becoming. It's not just a short-lived container or the serverless function. It is really a result of the decomposition of things that the code only does very little, because increasingly the value of what you're doing is in you calling into other pieces that already exist. Right? It's a very component-oriented way of doing things. And in that sense, you only add a little bit more function, a little bit more code to what was before a monolith, right? A very complex thing. In that sense, I think that's another dimension of being dumb endpoints. Gets more focused and more narrow.
I'm obsessed because of the foot injury that I don't need a monolith liver. I need it to be composed of several cells which can be replaced. And they're dumb in that sense. Maybe it's a crude representation, but yes.
Okay, I think you're trolling, but I'll bite. I think you're trolling, but I'll bite. So there are actual big critical applications that run in containers, VMs, that basically require SSH. And actually, big corporations subscribe to Red Hat services that take care of these things. So secondly, to the same point, so if you are so confident that thing SSH should not be there, I dare you to remove SSH, OpenSSHD from the package management distribution. That, I think that proves the trolling.
I agree. we are not ready yet. Clearly, we're not ready yet, and it's coming down. It's not down yet. And I agree. I mean, it's a fair. So if anybody was clear on that question or not, say from Red Hat packaged Mint packaged stuff, take down SSH. Don't ship it. And if you've heard of the container OS or the atomic OS thing, everything runs as a container. Everything runs as a container, which means if you're running Docker, which everybody's aware of, the Docker daemon itself or the Docker processes themselves are going to run as containers, system containers. The very fact that they are system containers, the point is nothing will run in the beginning. Everything is containerized. And if those containers are managed, what do you do when you SSH on the machine? If you're debugging the RAM failure, then yes. Don't do that. There are some problems elsewhere. If you're debugging any application, everything that you need by doing an SSH would hopefully be managed by the container orchestration system, where you know that system is running and everything can be funneled down and examined from outside of it. And that's the point. And I agree, it's not completely sunk in me as well, fully, that you would never need to SSH. But I think I'm beginning to see the light that yes, it's probably a fair idea.
I think you're seeing peculiars.
The comment is that I'm seeing peculiars. It is possible, clearly. You may be right, and I may be absolutely wrong. But the answer lies in the tussle, and let's explore more ideas there and discard the ones which don't work for us. And that's the idea of innovating then. Please, one more question, I guess. I don't want to run into time or further, I guess. A few more minutes?
One transition we have already seen where developers, I mean, even if we don't consider the containers yet, the developers are no longer logging into the host operating system, they are logging into the VM itself.
That's correct.
So that SSH is no longer required, or no developer needs to have that SSH access at that host operating system.
Correct.
So that transition has already occurred.
Right.
Now you are talking about another level of transition. Obviously, we will see that, but that could very well happen because you don't need to worry about who the container is running it.
I think. Thank you for supporting that, thing. But when you get to the machines, what do you do with the SSH? I'm not a good debugger, but I look at probably strace of the process. I look at how much memory is being consumed. Maybe IOStat, some network, what is going on. If it's logs, typically. All of this is available without logging onto the machine through the container orchestration systems. We're just not comfortable yet. With the system containers also, we will not require to do it, is my confidence, I would say. Misplaced, perhaps. No doubt about that. But it's in that world where things are running, and if things go wrong, we'll replace them. But the logic will permeate through and we'll be able to see. You could say I'm trying to trolling a big fancy idea, but that's fine. Any more questions? I guess that's it.
Thank you.
Thank you.
Can we have Omar on stage? We're just giving him the gift. In the confusion of moving from there to here.
Sure. Thank you.
Thank you. So MJ is our next speaker. Those who have come to our meetups before have probably heard him. So he's going to talk about getting your NFV platform to measure up with the NFVi kit. MJ has worked with DPDK team from 2009 onwards. There's another DPDK old timer here. Imran?
Dinosaur. We call ourselves DPDK dinosaurs.
Yeah.
And you are resilient.
Yeah.
Yeah. It's working.
It's working, yeah. See what you guys start with.
Even with SSH. It's working.
Yeah.
And without.
So yeah, he joined Intel in 1991, and he's held various roles and divisions within Intel. He holds 21 US patents, both individually and jointly. He was awarded Intel Achievement Award in 2016. So, yeah. Just wait for MG to get started.
Thank you so much. Can you hear me? Thanks. So I'm privileged to follow a visionary speech. So let us see how I do compared to. He gave the great vision, right? No SSH and great. So how many of you have seen, okay, I don't know what's happening here. So how many of you heard about this Intel Select solution? Anybody? Okay. So let me then step back. What is the top 2 reasons you will say the 1980 to 1990, the success the Intel enjoyed, right? The ramp. What are the couple of top technical reasons you would say the reason for that success? 286, 386, 486, Pentium Pro, continuous processors coming with various platforms. What are the top 2 reasons you would say for the maybe flawless execution of so many architectures?
Participation in Sematech.
Come again?
Participation in Sematech.
Participation.
Yeah, that was very important as a country and as Intel.
Okay, very good. Compatibility. Okay. Well, can you explain what do you mean by compatibility there, please?
Just like your 386 software can still run on Pentium.
Okay. Anything else? These are great reasons. Yeah. Is there anything else? Come again? Moore's law. Okay. So putting it at a system level, right? All of you are correct. So when you get a system, you are pretty confident that already it was validated with Windows running, with all those applications running. So the validation was done with matching things. Something is like I don't know where it is. Whereas right now, what's happening, right? We're talking about NFVi, SDN. We're talking about so many components running. What is happening, right? Let's say you go and get a system. You want to build a white box. You get a system, right? And then you go to DPDK site. You get the latest DPDK. You go to OVS site. Get the latest OVS. You go to OpenStack. Now. Let's say you have a NIC card, you get a driver for that, PF driver, VF driver, the NIC has a firmware, right? The NIC has a firmware too, right? Nowadays, the NICs are so complex, a lot of the developments are happening on the firmware. Each one of them has its own versions. How are you confident that all these things are going to be working with the whatever versions you are taking? Because open source is moving along, right? Various patches are going on. And so any issues that was there in the previous version crashed. Huh? Okay. So how do you make sure what you are building is pre-validated, pre-tested, and all these versions are working together? How do you know? And that is the value add for. I think this is hanging now. Value add for the Intel Select solution. Okay,
So Intel Select solution is something which Intel put together a list of various versions, and they document very clearly if you choose this particular platform and this particular NIC and this particular firmware version, various components we have validated, we have tested, this is the packet drop, this is the packet size we chose, and this is what it ran for so much time, you get that, right? And that's the value of Intel Select solution. Now when you have that platform and when you start with, and now you are developing your applications, you have peace of mind that whatever underneath is really something validated, right? Now that is, I think we talked about it 2-3 months back in similar setup. So today what we are going to talk about is next level. So that is something which you can go and get it from Intel, and if you go to the network developer site, there is a link where you can go and click and then you can get that system. Now let's say that is there in your lab, and you go and run your benchmarks, and that is a base benchmarks with a validated combination with a maximum optimized performance. What do I mean by optimization, right? You talk about DPDK and core running polled mode, but it is not by itself running. There's a Linux around it, right? Linux has scheduler. Scheduler can, even though you are thinking that your core is polling the port, but the Linux scheduler to go and schedule something else on top of that. Now you are not continuously polling, you are going and doing something what scheduler. Now there are various levels of things, right? That can be Linux user level process a scheduler can give to your core, which you think you are 100% using for polling. The second thing is it can give a kernel level task. A third thing is it can even give an interrupt to you. Now there are various levels of insulation you can do. For example, ISOL CPU. How many of you use ISOL CPU? Do you use ISOL CPU? ISOL CPU, that only solves the problem of Linux scheduler not scheduling user level processes. Still interrupt can be scheduled, still kernel level threads can be scheduled. So there are various things in the grub line command. So what I'm saying that is all these things are already done in that platform, and that you are getting value. Now so you have that, but now you have your own platform, right? Whether you are making yourself a platform or you are having your own vendor, from here you got your platform. Now how do you compare with this platform, and what are the processes you can go through to make sure the platform what you are going to be deploying can be almost equal to that in performance and all the compliance testing. That's what we are going to see today. I'm going to power off this machine now because it is hanging. So any questions? Anybody observed anything? Anybody from your experience have observed about NFV and in terms of performance, what Intel says and what you are not able to meet? You can share some of your heartburns. Anybody? You expected something and then you saw the document saying this is what we are meeting, but then you are not supposed to. You are exempt from answering. Anybody?
You can talk about non-voluntary context switches.
Non-voluntary context. Can you explain?
Yeah, that's with virtualization. You know, when you mentioned about the isolation of CPU.
ISOL CPU, yeah.
In virtual systems, many people using DPDK are hitting bottlenecks, problems about their DPDK application. And they never think about looking the hypervisor statistics.
Yeah.
About context switches.
Yeah.
There are two types of context switches, the voluntary based on interrupts,
Mm-hmm.
and there are also non-voluntary context switches.
Non-voluntary is very bad, right?
That called, basically it's preventing your CPU in the virtual machine to be working efficiently.
Correct.
While you think that it's working 100% with DPDK, something on the bottom is taking the CPU out from you.
Correct.
And what happens is that you are missing your packets. So for you, it's a packet loss.
Correct. Exactly. So that's what we talked about. Various levels of interruptions can happen, and Linux has some solutions, and the solutions can possibly cater to some of the disturbances, not for all the disturbances. One thing is ISOL CPU. ISOL CPU really solves the problem of any user level process getting scheduled by the Linux scheduler, but it cannot insulate it from interrupts, or it cannot insulate it from kernel level threats to be, and there are separate solutions for that, right? For example, RCU callback, right? Because RCU is a bookkeeping Linux is doing, and the callback can suddenly get executed. It is not a Linux user level process, it is a kernel level process. So even if you do isolve CPU, you will not be able to solve that problem. So you need to do something called RCU callback no on this course. So these are some of the grab, and these are the things which the select solution, or even if you see Red Hat has a lot of good performance optimization white papers. If you go through even the BIOS settings, right? What are the BIOS settings? So all those best optimization tricks and trades are being followed in the select solution. Now, when you have your own platform, how are you going to now go and do that is what the topic here. And there are some automation being done now. We call it as evaluation kit, and that automation takes care of a lot of hard work which possibly you had to do 5 months back, but now it's all being done automated. And I'm going to give some websites which you can go and repositories you can download and you can play yourselves. Okay. Any other experience? Anybody else? How many of you know about this interrupt controller called EPIC? Interrupt controller called EPIC. Can you describe what it does? What is the value add for from an operating system point of view? What it gives value?
It routes interrupts to various cores.
Come again?
It routes interrupts to various cores.
It routes interrupts to the various cores. Very good sentence, right? But okay, so what that implication for our NFV, right? For example, so because right now you are allocating so many cores only for your purpose, right? You want to do your polling, and here is your EPIC interrupt controller who wants a fair usage of systems. So he thinks the interrupts should be going to distributed way. So he's going to spray the interrupt, and suddenly one interrupt comes to your core, right? Even though we are saying poll mode, we are talking about for the NIC we are not going to get interrupted, but then there will be other interrupts in the system, and that EPIC and the OS can schedule on your core, and as you was pointing, your core will be taken away from you, and it is going and servicing interrupt and coming back by the time packets are gone, right? So there are certain other Linux flags which you need to set up in the grab. So those are the minute details. So it's not just getting a system and then start working on your code, putting your software, and then figuring out why performance is not good. Another simple question, right? Nowadays when system vendors ship their product, green certification, right? Is it optimized for performance, or it is optimized for, you know what I mean, power savings? What do you think? When they're shipping it with a green certification, what it is optimized for? Power savings or performance? You want performance in the platform, but when they ship it, what it is optimized for? The green PC, the BIOS settings. How many of you know something called the C states? Intel CPU has something called the C states, sleep states, right? Deep sleep, light sleep, right? Various things. So they have optimized for the BIOS settings are optimized, and they ship it for green PC, which means it is going to be in the sleep. Whenever there is a slight inactivity, it is going to go sleep. And so if your packets are coming dispersed but in bursts, you are going to have a latency because it's going to wake up from sleep. So you need to set the BIOS settings such that it is power optimized, not power optimized, performance optimized, not power optimized. So what I mean by that is, right, so it's not just getting a system as it is and start working. You need to do a lot of these things, and those are the things that are done in the startup select, what do you call, select fast track kit, because that starts you on a fast track. You don't need to go through all of that, right? So that is what early adopters biggest chasm is in terms of getting. And again, we talked about a lot of software components. You are able to see all the components, KVM, QEMU, and OBS. all the versions have to align, right, to make sure you are in a same ballpark zone as what is validated from Intel. If not, you possibly will get into some issues which nobody else has seen before, right? So if you look at HC NFVi architecture, you can look at as two things. One is infrastructure, another is the above layer where the value add is by the vendors. The infrastructure, if you map it, basically firmwares and drivers, and then hypervisor, and then the host components, guest components, and similarly all the drivers and firmware versions. So that's what is being done now. That's select fast track kit. Now this talk is about, once you have that, now you have your own system. What are the things that you can do? What are the facilities that are available? What are the tools that are available for evaluation kit in terms of what tests you can do, what checklists you have, hardware and software. And then again, if Intel gives you a number, now you may have two different systems in your budget, cost wise and then performance envelope wise, right? You may be having a sweet spot platform which is slightly lower in price, and then another system which is like higher in performance. So you cannot have same performance metrics for both. So that's why we have two flavor called base and plus, and then the performance metrics are different. And so how do you test, and what are the checklists, and then if there's a deviant, how do you install the best known configuration? And that's the key. That's what we call about enabling kit. So you have your own platform, and how do you do? And what we have done is, we have a team in Taiwan. What they have done is, they have done this USB, right? The USB has pretty much, apart from OS, everything, DPDK, OBS, QAT, all of that installed, and you just plug it in the system, it comes up and it installs all the good known versions, because now you want to verify whether your platform is well optimized, and all the software comes with it, and then it installs. And very first what you're getting is the menu. Pretty much you get the menu to run the tests. So now I was talking about all this various knobs, various performance tools, bias setting, graph. So how many of you see the cookbook? We just published the cookbook last week. I'm going to flash the link if you want to take a picture of that. And that cookbook has like almost 7 chapters. It's like Sham series type of book, right? So 7 chapters, and each chapter is like 20 minutes. So if you are very new to DPDK, if you want to just sit on a Saturday afternoon, so 30 minutes, 40 minutes, you want to develop a project by yourself. So that's the first chapter. You develop how to do a traffic generator using DPDK. So like that. And the second chapter is more like a loopback test. The third chapter is more like control plane and data plane synchronization. And then the 6th chapter is more like a 40-page of performance optimization. So that's something we just published last week because of a lot of interest from developers like you. So that is the website. That's the URL. I think March 7th we published. So you can go and look at it. And then I think chapter 6 is performance optimization. Many people liked it, and many people felt very useful, developers as well as customers. And then chapter 7 is vTune. How many of you used vTune? Okay. What do you liked about vTune?
You can find the hotspots of the given application.
Okay. You can find hotspot. What else you can find?
Memory consumption.
Memory consumption. Right. And then many of you might have felt DPDK always the core shows 100% utilization. Even though it is not doing anything, it is giving wrong information. Of late, the vTune has been updated with the DPDK event. Thereby, it can really show useful work what is being done. So you can go and look at that DPDK hook they have put in. So when I say the measurement, right, there are multiple dimensions. One is crypto. You have how many of you gone to the hands-on today on crypto? Okay. So those things, crypto and compression measurements are done, and then there are benchmark numbers which you can compare with on your platform. So Intel Select Solution is giving with this CPU, with this QAT version, with this NIC card, this is the number you are getting, and then you can compare that with your platform. And if there is something wrong, there can be multiple reasons, right? One is possibly you have plugged in the card in a wrong slot, because not all slots are equal. You may be thinking that I have PCI slots equal width should be same performance, but not necessary, because they are all going to CPU. Inside CPU, the designers might have made some trade-off, and one PCI bus may be more performant than the other one. How do you know that? You have to look at the schematics. How many software engineers look at the schematics? We don't even open the box, right? So it may be in the wrong slot. So things like that, you'll be able to compare by running that. Similarly, packet processing, RFC 2544 DPDK test that runs, and then we can find packet processing. Now, how do we do that? I think I will, if time is there, I will run the tests. What it does is it runs at the maximum packet rate, and then it does binary, and then it converges to find it meets the 0.001% packet drop. Does it meet or not? Depending upon that, it keeps reducing the throughput, and then finally it gives the number whatever platform meets. So that's the RFC it goes through. So all these things are already coded, and Python scripts are there. It is running. Okay. Similarly, the QAT at a system level, OpenSSL and Nginx, you can look at the connection and speed per second. So all those things are there, right? So if I ask you what is important, right? Is it functional correctness? We talked about various versions. Mismatch can take you into some la-la land. So how do you make sure, the versions what you have? Functional correctness, extracting full performance. That way we talked about, ISOL CPU and, RCU, no callback type of things. And then tools to probe and report status, the above two things. And then tools to control. When I probe, after that, how do I control? And what is important to you? All of the above, right? Normally, always that's the case, right? So let's go through one by one. Functional correctness, I think we talked very quickly, but I have listed so many different software versions are there. libvirt version, QEMU version, firmware. So how do you make sure all of that moving parts, right, are according to what is tested? And some of the problems, as I was telling, right, not all slots are made equal. How do you know? There are various scripts and there are Linux commands which you can find out the slot where you have plugged in is a higher performance slot. Not only that, the speed of the PCI slot, all of that you can find out. Okay. Now this is a real life case. There was one customer who had got this 2 CPU socket system, and the performance was way off. As software developers, they never opened the box. They never found out what it was in that. But what you see here is 2 socket system. This is memory, right? Are you able to see memory here? All these are memory slots. This CPU had no memory populated, 0. So they got system somewhere ordered, and it was no memory populated here, and here a meager memory was populated. Only one slot was populated, and there was a slot, IO slot here, IO slot here. The PCI slot, the NIC was put in this slot. So what do you think will happen? This CPU, if it is going to service this NIC, it has no memory for itself. It is going to use a remote socket. But let's say if you give the polling to this CPU, it has a very small amount of memory, but to service it has to cross the UPI. So this is a simple example of not knowing the system's configuration. So what if a way that you can compare the reference platform that all this matching components, moving patches, everything matches. So that's what we mean by conformity test, and that's what comes with that package for you. And the benefit for you is like, you run that. That was the thermometer I showed you, right? You run that, you feel, okay, now the system is meeting that requirement. So, and then you can start developing your stuff. But what if it does not meet, right? So when we say various components, DPDK 16.11 is the latest stable release. Any bug fixes that is happening, we will always backport to 16.11. So this stack is pretty much maintain that. Now this is the link if you want to take a picture. This is the link where you can order that kit. Okay. So if you want to not spend time to make sure you are doing all the hard work to make all these planets to align, this is the place to get that already available for you. But now once you get that, then you are having your own system, and that's where you want to do performance measurement, right? Because the system which came from Intel, what you ordered from the previous link, has everything. Now you have your own system which you are going to deploying. That now how are you going to measure? For that you need to know whether that forms similar to the base platform or plus platform, because there are two variants, right? The base platform is what the price performance is like sweet spot, and the plus is purely optimized for performance, higher price range and higher performance range. So once you know, then you run corresponding script, right? The script has like something like a option, command line option to say base or plus, and when you run that, then you will see what is the measurement on your system, and it also spits out in red color saying these numbers are not okay or these numbers are okay. So you'll be able to look at the eyeball, you can find out, right? So that is the big picture. Now we are going to get into the individual. Quickly I will flash, I'm not going to go through detail, because the previous link, when you go through, you will see a document which talks about all these things, right? So the second thing is packet processing, right? Packet processing is the RFC we talked about, right? That's what it runs. It runs L3 forward, basically 2 sockets. It runs, how many of you are familiar with the T-Rex packet generator? It has a stateless, stateful, both mode. It can, it's a packet generator. It's a Linux Foundation piece right now. So it's a software packet generator. It can run both stateful and stateless, and also you can allocate cores for measuring latency. You can allocate cores for measuring statuses. So it's very well used, and a lot of open source projects like network service benchmarking, VPP, many others, OPNFV, all of them use T-Rex as their packet generation, as well as device center test, right? Because you are generating packet using T-Rex, but here the device center test, you can have test PMD, or you can also have T-Rex, and many of the open source projects are using T-Rex in both places. The T-Rex also is like acting as a poll mode driver, but it can do much more than that. It can measure latency and other things. Okay, so that's what is being run in this. And so we talked about packet processing, right? The next thing is system level, OpenSSL and OpenSSL Nginx. So there are test scripts written for that, and it runs that. So this is the website. If you want to take a picture, you can take this. This is the Intel_NFVi evaluation kit. So if you go there, the clone or download, if you download there will be instruction how to create a USB stick. It is a bleeding edge. So if you find some issues, feel free to report it. Don't feel shy, because a lot of proxy things they are fixing right now. For people who are inside Intel, this works like a charm. But people outside Intel, they need to do some tweaking to some files proxy. So those are getting documented. So don't feel shy. Just take a screenshot if you are having any issues, and then communicate. These are the websites if you want to take a picture of this. Actually, this is like not yet released out. It is possibly some of these things may need access right for you to ask for permission. Okay. How much time I have more? Oh, I have too much time. Okay. Let me stop. Is there any questions? Anything I'm addressing? Is that useful? What we are talking about, select solution? Because the way I used to look at it is Wintel, right? Windows Intel combination. I asked the question, what was the reason for success? That Wintel was the reason for success. And in communication space with the NFV, I'm thinking, right, having such standard tabulated, documented, validated information and given to customers, either in a form of platform or in a form of script which can run on their own platform, should create similar success. Because right now, if you do not know what you are putting together to get a system, we don't know what is happening underneath. So do you see that importance of that? Or do you see, is there anything that can be improved upon if you think something is missing? Any input? Any comment? So let's see whether I can run that demo quickly before my battery runs out. How does that, if I run, okay, so let's say, how does the menu come up? So when that USB is put in a system, right, the system boots from the USB. When you go to the BIOS and then you say boot from the USB, and that's what it comes up. Very first it comes up with the menu to show you, pretty much it just comes here. Okay, so one is the document guide, second is like download the best known configuration software package. So this is the block diagram, right, where I talked about 2-socket system. In one socket is a package generator, another which is T-Rex, another socket is that data center test, that's also is running T-Rex, and you will have back-to-back loop back basically, right. This is the document, this is the test environment, and then when you select 2, it will go and download the best known software. But the USB based thing already has a software, but before the USB we had this way of going and downloading the best known software, right. See, I'm just telling this, but from 2009 I will say till 2000, I will say at least 2015, how many years, 6 years, was a big fight. Without having this best known configuration, customers used to put anything they wanted to put and then they will raise their hand, right, and we don't know where they are off, and we ask questions, do you have this kernel, and they will say yes, but our document says, DPDK document says you should have kernel this and above, you should use huge page. Many customers read it, they gloss over it, they don't do it, and so the performance was not there. But now we have some fixed numbers in terms of what they have to do, type of thing, right. How do I okay, so that is the so let's say you go and download, right. What are the downloads? Let's say you choose number 2, download best known configuration software. So it downloads DPDK 17, and then it downloads what? Crypto, right? And BPP, it downloads BPP. So and then let's say you run this L3 forward RFC, you just run it. Now you have your system and you are running that. Now you will be able to see, compared to the Intel Select solution in your system, when you run this, that it is going to go and it is now compiling. Okay, IGB, UIO, how many of you are seeing familiar? T-Rex, are you able to see T-Rex here? T-Rex version 2.27, I think the latest one is 3.232 if I am not mistaken. And so now it is running the test. So what it will do is it will run it with a throughput, and then it will find out whether the drop rate is meeting the criteria. If it is not meeting, it will reduce it. It will in a binary fashion. This will go for like 12-13 minutes. So, but you got the idea, right? So, and then similarly we have Nginx test and OpenSSL test. All of that can be run. Okay, I'm not going to go through. Okay, so with that, let us go quickly the files. It's 7:30 already. So again, the document gives very cleanly how should you give the command lines, right? L3 forward. How many of you know this 005, 016, what it means? Do you care? So what it means is this particular, the 3 digits are port, queue, what's the other one? Core, right? Core, yeah. So because you may have multiple queues inside a port, so you want to specifically tell which core you are connecting to which port and which queue, right? Now, how many of you know that the BIOS writers have so much freedom, nobody dictates them what numbering they have to give. Let's say you have 2-socket system, 72 cores in this, 72 cores in this, 144 cores. the numbering, how they should number. Nobody has given them constraint. So a BIOS writer for a platform A can do numbering 0 to 72 here, and then 73 to 144. Another BIOS writer can just change their mind, and they may say 0 to say 36, and then 37 to 72, and then 73 to remaining half, and then the last half there. So now what happens is, you may be thinking 34 and 35 are the same socket. Maybe that is true for this BIOS writer and it may be working, but now if you use the same software in that platform, that BIOS writer has changed his mind. So now your core will be handshaking across sockets, and you will be having, bad performance. So that's the reason why we very clearly use those things, right? So okay, so what was the pre-work that was done? I think these are all details. Once before, so right now, as I said, it is bleeding edge, it is not cutting edge. So the developers in Taiwan used me as a guinea pig. They said, you don't need to do anything, just put it in, it will work. No, it did not work. So I just gave them the laundry list. I had to do all these things before running them. So it's very simple. But these are the things that they were missing last week, so they are fixing that. I just kind of putting it for completeness. And then once you install the Intel NFVi evaluation kit, the directory structure, what it will look like, it will have a script, it will have output directory where it will output all the. So this is what I was talking about. When you go and take it, you may have a lot of proxy issues, because I was doing this from my home office, and these guys are pinging within Intel, and then it was not working for me. And they were thinking that I am working all these things from Intel. I said, no, I'm on VPN, but I am from my home office. It did not work. So then they said, well, then we need to do a lot of proxy changes. So those are things that are right now in progress. I think we went through this, right? We went through menu option 1, we went through menu option 2. You saw the video. So we have both hardware checklist and software checklist, right? One of the hardware checklists I talked about was plugging it in the correct slot. It maybe sounds simple, very simple, basic, but unless you go and look at your schematics, find out which is a high performant NIC, you will miss it, right? And similarly, whether all the memory slots are populated. Suppose you are getting a platform from Intel, right? Intel, you are a spoiled customer. You just ask Intel. Go ahead.
The question I have is that, does the tool itself tells which one is the high performance bus?
Yes. It does, exactly.
So that I can open the box.
Yes.
If I ran this software, then I can open the cage and
Right.
I can put it in the.
Correct.
And I can put in the right
Yes.
slot.
Correct. It runs and then it gives you in red color wherever things are mismatched. It will say your slot, you are not put in the proper slot. It will tell very clearly. Yeah. So let's say you are a spoiled customer of Intel, right? And then your sales guy, the Intel sales guy, you just pressurized him and you got a free platform. Now, when Intel gives you free platform, they are not going to populate all the memory. They possibly populate one memory in one socket and no memory in another socket. So if you run as it is, you cannot expect. So you want to populate all the memory DIMM channels, right, depending upon your use case. So that's what I meant by hardware checklist, and software checklist is pretty much their version numbers, very dull and boring, but how many of them, and definitely I don't think anybody can get all those things right, so it's better to go through the conformance test. And again, you have base and plus, and if you can see, like a base is slightly lower cost, sweet spot combination. So if you see the memory population, memory requirement and all those things will be slightly less compared to the plus system. Okay. So what if my checklist does not match? So what are the tools that are available? So this is what you were asking a question, right? So if you see here, you are able to see this one. It will say very clearly failed, chipset test failed. So chipset test false, passed. So maybe if you run the base, sometimes it may pass, but if you run the plus, it may fail. So depending upon how stringent the requirement is, right? So this shows you base, it is passing, right? Ubuntu.sh base, it is passing, whereas Ubuntu.plus, it is failing. So that means the chipset is not meeting in your platform the conformance level of plus. Similarly, it does all this CPU list, siblings, checking the hardware. It is doing all the checking the hardware, memory, right? It says if you are looking for plus confirmation, you need to have this much memory. You do not have that. And NIC, it is checking the firmware, and it is checking the speed. This is what you are talking about, right? The speed, 8 gigabits per second, and width into 8. Is it connected in the proper PCI slot? And then firmware, it is checking the NIC firmware or the NIC. Similarly, NIC NUMA, right? And so wherever it fails, it clearly tells the reason why it is failing. Q80 engine, you have only 1, only 0. Non-volatile memory failing, BIOS configuration failing, and it gives a reason why it is failing. Uncore scaling enabled. That's the reason it says you have selected wrong combination. Similarly, for the driver, right, it says IXB 10 gig 5.04 is needed minimum. For 40 gig 2.0.26 is needed minimum. If it is not, it is saying failing. Similarly, it finds QEMU, libert. So if all of them are missing, everything is green, right? So simply that. So how do you correct it? Now that it is failing, how do you correct it? That's where initially we had this lot of scripts. Now it's all USB based. You just go through that steps and you will be able to auto install instead of doing manual install of selected combination. And initially Intel was giving along with the OS, but then we got notification that you cannot distribute OS, you can only distribute other components. So now we are having a mechanism through USB stick, not distributing OS but all the other components. So this talks about various other components, what it has, various directories, firmware directory, driver directory, utility directory, script directory, and then what each one of them are. If you see the firmware directory you have for 412, that's the 40 gig, 90, 10 gig, driver, 40 gig driver, correct combinations, Q80, right, virtual function, physical function drivers for 10 gig and 40 gig, utilities, DPDK, related things, SPDK. How many of you are attended the SPDK today, right? Thank you. So pretty much that's a demo we saw, right? And we have two flavors. One is Ubuntu flavor. The Intel Select solution comes in two flavors. One is Ubuntu, another is the Red Hat Linux. So this talks about proxy, something you want to look for, because I think that's where you have to do a lot of work there to go and change some of the configuration files. Apart from that, I think we talked about T-Rex, right? T-Rex is what is being used. So if you are not familiar with T-Rex, take one evening, go through that first exercise of the cookbook, because I think T-Rex is becoming very key in terms of usage in all the open NFV platforms. So this is just quickly showing what T-Rex package photos are: stateless, stateful, and then various config files. Very, very exhaustive things it can do, T-Rex. I think I'm done pretty much. Is there any other questions? I don't want to hold you guys 7:30 already. Is there any other questions? I will take some couple of questions and we are done.
Actually, Lakshmi is running late, so you can go ahead.
Oh, okay, no. So you can come and talk about next meeting and all. That's fine. Any other questions? Any suggestions? Anybody has done similar thing from the different architecture? Go ahead. We had this demonstrated in last week in Bangalore on Saturday, right? Saturday, people from flew from Bombay, and a lot of interest. Go ahead.
Yeah, this is like something like a standardization of platform hardware configuration, and plus whatever runs on it. Correct? And it will work fine.
Correct.
Suppose if I design my own hardware, motherboard, different kind of configurations, different kind of, then I run something else on that one, then it will.
That is something to look and refer, right? Okay, this is not validated combination in terms of software. Suppose you design your own hardware, but still you can go through the benefit of going through the software components which are all matching, and you can run the script because same, even though it's a different platform, let's say it is x86 based, it will run on that, the script will run on that, and it will tell you where it is deviant, either in hardware or in software.
Or if I have support different number of slots or something,
Correct.
configuration is different.
Correct.
then
It will tell you, yes, yes.
Other thing that I is actually what was going on in my mind when this presentation was going on was actually earlier days we had standard CPU and whatnot, and then
Yes.
that one was the base really speaking, and that's how we take.
Correct, Wintel. Yeah, that's what it is, yeah.
In this case, we are thinking of now next level standardization at
Correct.
platform level, then
Correct.
we at processor level, and then
Correct.
what is taking.
So you don't need to worry about lot of because I have been in situations where customers have deployed machines and then it broke, and then finally it was some wrong version they used. Now you are
That is standardizing at
Yes.
level,
Yeah. Yes.
getting more performance.
Correct, absolutely. Then only you can scale out, right? Yeah. Thanks.
So this tool is basically for ensuring that the Intel platform is NFVi ready, right?
Correct.
Now, one question is that why this tool cannot be a part of the system itself, like part of the BIOS or something like that, where you run it from there. Like,
That's what is the Intel's fast track circuit is, right? So suppose you want the peace of
you
mind.
need a USB or something like that. Right?
That is okay. So the Intel Select Kit comes with the correct combination installed. You don't need a USB there. What I was saying is, let's say you have your lab and you got one, and now you have your preferred vendor from whom you are getting your hardware. Now, how do you make sure it is closer to that? Is what the USB and then script to run it.
In the old days, I remember that there used to be a BIOS test. I don't know whether it still exists or not, but we used to run a BIOS test,
Yeah.
which tells that whether certain settings or your BIOS is like correct or not.
True.
I'm talking about quite some time ago. Right?
True.
But I'm wondering that if this option is available, something like that.
So I think you are 2 steps ahead of us. That's what is happening now.
Okay.
Because now this is becoming almost a standard. Now NFV vendors are asking, hey, is your system went through this compliance test? This we never thought that will happen. That is happening now. So now they will put it as part of that. Good point. Any other questions? If not, I will give you time back. Sujata, you can come and talk about April events.
MJ, I have a question.
Oh, sure.
So, a newbie question. I noticed one of the tests, it said it needed 384 gigs of RAM. What the heck is it doing with 384 gigs of RAM?
I did not see that. I will get back to you about that. I don't know. Maybe it's a plus.
It was one of the failures.
Oh, really?
Yeah, it was insufficient RAM, and that unless it's been a long day. Maybe my eyes were reading something different, but
Okay, I will find out on that. No, I don't know the details.
Yeah,
Why it is? I know it will tell you what it is, but I do not know why it says that.
yeah,
Maybe it says that all the slots will be populated. Very rough as that. I think Lakshmi is here. Yeah.
I mean, you have 112 cores. Does it just basically because you have all those scores?
No. The system with 2 sockets will have this many memory slots. If you populate all of that with the current technology, that's the number we are getting, right?
Okay. Thank you.
Okay, thank you very much. Lakshmi is here. Thanks.
You are free. Here. So he's gonna get that wired up if you can stall and hang again, and then I'm gonna get you wired up for this. So we need to attach those two.
So now we have Lakshmi Sharma to talk about GCE.
not sure exactly where you want to put
I
that.
think just hand. She's director product
do you want
management
both?
at Google.
One's for
Okay.
the camera and one's for
20 plus years
so.
of experience in enterprise service provider and IT networking and security and compute experience. She offers a unique blend of experience of defining and executing strategy for product teams on vendor side and implementing the same at customer side retail. Who were here for our January meetup? Anybody? Okay, online. She was on our panel and she's also speaking at ONS. Who's going to be there at ONS next week? Oh, I covered up the hands. Yeah. Okay. Okay. Stop recording. Oh, okay.
Live stream and stuff.
Okay, so we can stream but not post it, like whenever. Okay. So, Ron, you got that?
No.
Sorry everyone, I can suggest some logistics. So if it streams the post, but then it will remove it from the let's just not stream it. Yeah, let's not stream it. Okay. So if you, this is like this might have been done somewhere, but I'm adding that into the register. Yeah. I'm so for they won't get to see. For those watching the stream, we're sorry we have to stop the stream right now because what Lakshmi is about to present, she didn't get formal approval. So she's not okay with recording this, and if we stream it, it will be recorded on YouTube. So we're sorry. We are cutting off the online stream at this point.